Okay, so here's the next problem that we're going to do. Here's a set of instructions that you see on a test. Generally, with the last line there, I put one line and say everything that follows. So we want to simplify. We want to give the answer in simplified radical form. We want to assume all variables are positive. What that sentence means, assume all variables are positive, is I do not worry about absolute values. If you don't see that, or if you're trying problems in the book and you see the absolute value in the answer, it's because they don't know what may or may not be positive, so they're ensuring that things would be positive. For right now, I just want to work on the process. Okay, so square root of 48, ab cubed c squared. This is always going to be your key. This here. We understand this to be a 2. We want to remove all perfect squares. If that was a 3, I'd remove all perfect cubes. That determines how I want to simplify this. Now I'm going to go through and I'm going to do a specific process here. Okay. In the next clip I'll give you something a little different. The third clip I'm going to give you the process that you're probably going to lean towards. Okay. The variables will be easier. You're going to be able to see that there's a factor to remove. Index is 2. I know that there's factors to remove if there are powers that are equal to or greater. Well, I've got a power equal to, I've got a power greater. We want to work our way till we have powers that are less than. Okay? So right now I know I can't do anything with the a. The number is where you're going to struggle. I'm going to give you a process so that you can go through. Okay? So here's what I know. I know that the power matches an index. So I know I want to be able to take that out. I know there's nothing I can do there. Here, like we saw in the last one, I can deconstruct that. So when I deconstruct, I just rewrite it. I know I want to rewrite it in terms of the index, but I always want to make sure I have accounted for all the values, all factors that I had. I had 3 factors of b. Here I've got 2. I need to represent it with another one. Okay? So I know this now will come outside the radical. When I say it will come outside the radical, I'm talking about just about the base. We saw in the last clip, these 2's will basically cancel out. Now 48, here's the process I want to go through. 48 is a composite number. It's made up of other numbers. Prime would be one in the number. This is like a various bunch. Now, if you remember your prime factorization tree, where you just divided by prime factors, we're going to build on that. What I want you to do is similar, but I want you to divide by your perfect squares. So that's another reason I want you to know them. So I start with 2, which is 4. Okay, I see if that divides in. Well, 48 is divisible by 4. I want to hold on to that because I'd rather do this in larger chunks. Well, I also check if that hadn't gone in, I would have gone to 3 squared, which is 9. 48 doesn't go to 9. If that didn't work, I check 4 squared, which is 16. Well, here's the thing. If 2 works, I always look to see if 4 works, I always check to see if 16 will work because 4 is a factor of 16. Well, 16 actually goes in. This breaks down to 16 times 3, or 4 squared times 3. If that hadn't continued, I would have gone 5 squared, 6 squared, 7 squared. At some point, I get over halfway the number. So half of this number would have been 24. So 5 squared is 25. If nothing had gone in, I know there wouldn't be anything I can take out. There may not be anything we can take out. So when I look at this, that 4 will come outside. So my process, I just go through and I underline the items where I'm going to take out the base. So I know I'm going to take out a 4. I'm going to take out a B. I'm going to take out a C. When you take the information out, remember, this is all multiplication. It's still going to be a multiplication there. No 4 plus B plus C. We're not adding anything. Multiply. And just like everything else, alphabetical order. Okay? So 4 times B times C, those are the items that I underlined. Everything else has to stay inside the radical because the powers are less. So I had a 3, I had an A, and I had a B. So that's the original. This is the simplified radical form. So this meets that first rule. remove all nth powered factors. I've removed all perfect squares. And when you look at it, if that's a 2, all these powers are less than that. Okay? Let's erase. Yeah. So we're going to use that same set of instructions. We're going to use that same set of instructions, and we're going to utilize let's do 5th root of 96 x to the 7th y to the 42nd. Okay, so I want to simplify. Now, as you go through the breakdown that I did, basically I did the product rule in reverse. Here I'm going to do something a little different. Again, I'm going to start with the variables and break those down. Okay, so 42, or the x to the 7th, I could break that down x to the 5th times x squared. Right? 5 plus 2 is 7. So I've rewritten that. Well, here's the thing. I don't want to go through and say y to the 5th, y to the 5th, y to the 5th so many times, right? 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. I'd have to add up to 42. Here's something we can do. Instead of doing that when the numbers are large, we can, I mean, by all means, if you want to do that, by all means, take over. Well, here's the thing. I need the power to match the index. What I can do is I can break this down thinking about the power rule. I know the base is going to be y. I have to think, what do I have to have here that'll get us to the most of what we have here? Well, this is where knowing multiplication tables will help. Well, we could say 8. 8 times 5 is 40, right? But I have 42, so that means I have 2 others. So when we do this, that power is less than this index, so that's going to stay inside. But in this case, this power matches this. This now, this y to the 8th, is my base. That will come outside. So right now, I know I'm going to take out an x to the 5th. I'm going to take out a y to the 8th. I know inside, I've got a 5th root, I have an x squared, and I have a y squared. Powers are less than the x. The number, again, the number will be a struggle. Okay, again, I started on this. This is the product rule in reverse. I would need 8 y to the 5ths to get there doing that. That's a relatively small number from what you could see. So if you want to use the power rule in reverse, set out the index to match the power, set that up like that, and then figure out what I'd have to multiply by to get to the greatest part of this. Okay? Well, 96. If I go through and try to break that down, again, I start with 2, and I raise it to the index as a pattern. A lot of times students will, I'll try to divide this, try to divide this. Here's a pattern for you. 2 to the 5th. Well, 2 to the 5th is 32. Does that divide in? It actually does. So 96 divided by 32, or 2 to the 5th, goes in 3 times. So 96 is 2 to the 5th times 3. I can rewrite that. Well, that power matches index, so I'm going to take this out. That 3 stays inside. So I have a 2 and I have a 3. If this had not gone in, I would have gone 3 to the 5th. Then 4 to the 5th, 5 to the 5th. And remember, there's a halfway point. You may not be able to find anything in terms of what that index is. 2 to the 5th, 3 to the 5th, etc. So, remember, power matches the index, take out the base. That's a 2. So this is our simplified answer. Shoot, goes right through it. Okay. In the next clip, I'm going to go through a mechanism that I think most of you will like. I've been showing this over the last few years. This is the product rule in reverse, what we did here. When numbers are small, that's easy for you. When the numbers are large, remember you can do the power rule. And this is still part of the product rule. I'm going to go through and show you a mechanism, a shortcut, and it kind of incorporates what we did there. And this is something you can do on most of them. Okay, so I'll show that in the next clip.